Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Fergus. Hi Fergus, tell us a few words about yourself and about the tool you want to show us.
Hi everyone. Yeah, I'm Fergus. So I am the CTO of a company called Titanml. We're based in London and we work on machine learning optimization, especially with large language models. And the tool I'm going to demonstrate today is the Takeoff Server, which is a product we've built recently for deploying and optimizing large language models locally. We're trying to build the fastest and easiest way to get started with these things so that you don't have to rely on OpenAI APIs and these kinds of things, and so you can manage the whole process yourself.
That's pretty useful.
Yeah, I hope so.
Okay, well, you probably have a demo for us, right?
I do, yeah, that's right. Okay, so yeah, today, so I'm going to demo the Titan Takeoff Server. This is an open source project that we work on here at Titanml. The goal is to make a very fast and easy way to deploy large language models locally, whether that's on CPU, on GPU, your laptop, on a server that you want to run inference on, anything like that. We want to bring all these optimization techniques to users. And so we'll see the GitHub and stuff later and how to contribute. But for now, let's just have a look at what we enable when we use this technology. So first, I'm just going to show there's an open source model called Falcon, which is a large language model that responds to users' conversations. And so you can use that to build interesting LLM-enabled apps. So chatbots, so you can use it to produce content, say blogs, etc. You can use it to do all kinds of things like that. Anything that you might want to do with AI, you might use this model to do. Takeoff Server supports all kinds of things.
Is it like
particularly, yeah, reasonably good performance. It doesn't require you to sign any forms and produce tokens like the llama models do if you want to use them. And they're all supported in the platform, but it's just a good mixture of price and performance. Footprint and performance, they're all free. Anyway, and so yeah, in order to run the Takeoff Server with the Falcon model, I'm just going to run this command here. You just make that screen a little bit bigger. And so it's iris takeoff. So we start by installing the package. So we install, and we want to upgrade because I happen to have it installed already. And so it's just normal Python pip. So if you have used Python before, this should be reasonably obvious. And then from here, that will install the iris launcher, which is we use to launch these servers. And so this command here is what we use to launch a Falcon model server. And so
so this is like model, this is like GitHub user / GitHub rep, or what's
that? Exactly, that's right. So this is Hugging Face is a repository for open source models. And so this string here is the string of a Hugging Face model. If you go to our documentation, you can see how to load your own local models into the server, but this model string can just be a Hugging Face one, and it will download it and run it automatically. And then we also specify the device. So I'll show using GPU, but we can also do it on CPU as well. And so let's press enter. And you see it starts the server. We have a little bit of thing. So the server boots up, performs the optimization process. And if I copy and paste this command here, we can see that there's now a server running. So some logs. And then now that we have a large language model running locally on our machine, we might want to talk to it. And that's what language models are for. So where we interact with these things, this is a REST API. So if you're a developer, that's something that will make sense to you. You can send requests to your server. By default, this runs on port 8000. You send requests to your server and you get responses back. In fact, the server makes sure that you get your responses back streamed so you can build interactive applications like ChatGPT does. So for example, here I'm asking what the capital of France is. You should see the tokens will immediately stream back. And so for example, here I might ask, what are 3 good things to do in London on the weekend? Send question to the model and then it'll instantly stream back the responses. And behind the scenes here, we have all kinds of proprietary, interesting optimizations that are being performed, as well as open source ones. Actually, there's the open source ones, so these aren't proprietary. We have this open core, we have like an open source core, and then you can also build other things around that. But here we use a bunch of open source techniques, which you can see on our GitHub. And so, yeah, we perform these optimizations, produce an optimized model, and it runs these large language models incredibly quickly, locally. And so, I mean, any kind of question you might like to ask in the model is...
Yeah, like I'm curious what kind of optimizations are there? Because I know that deploying LLMs is a pretty challenging thing, because they are big, they're heavy, and yeah, so I assume that these optimizations aim at making it easier, right? So what kind of optimizations are those?
Yeah, it's absolutely true. I mean, these are very heavy models. This is a model with 7 billion parameters. 7 billion parameters. Each parameter is a single floating point weight. That's, say, 4 bytes in memory by default. And if you add that up, that's something like 4 times 7 is 28 gigabytes of weights. Just
yeah. So you need to have a pretty big GPU, right, to host this single model.
In principle, you do. That's a very nice
but
segue.
You do something that
with clever optimizations, you don't. So what the Takeoff Server uses is something called quantisation. So by default, these weights would be in 32 bits, which is this 4 bytes per parameter thing. But we do intake quantization by default here. So we take those high precision weights, and then we carefully tune the precision so that we can actually represent them by much smaller weights. And then this intake quantized model runs much faster and in much less memory. And so, for example, here we've gone from a 7 billion model, which in principle has 28 gigabyte RAM or VRAM footprint, to one that has only a 7 gigabyte RAM or VRAM footprint.
I have a laptop with a GPU, and this GPU has only 4 gigs. Can I still use this Falcon model, or I need to use a different?
No, this model would be slightly too big for that 4 gig GPU, but you probably would be able to run it on CPU on your laptop. Okay. So depending on how much RAM you have.
16, I think.
Yeah, so that should run. Yeah, it's a little slower, and I can show the speed for CPUs, but yeah, that should run. And then you can run smaller models on the GPU and get a bit more speed out of those. So that's cool. Get one more response from the model, just because I think it's cool how quickly these things can actually run. And so, yeah, I mean, we can have a look at the CPU inference as well and show the same model inferencing on CPU. But first, the Takeoff Server also bundles some nice user interfaces that makes it easier to kind of explore what sort of performance you get from these models. And so this is just the API structure. So if you're a developer trying to build on top of it, this is what you'd use to figure out what you can send and what you'll get back. But we also bundled some, like a simple chat interface, right? So like, what's the weather in... So the model pretends that it knows what the weather is. It's a good guess. It's almost certainly not correct, and you can really test out.
Yeah, it's probably more now, right?
Yeah, probably.
Berlin right now, where I am currently, is 30 degrees. It's like quite hot today.
Oh, nice. Yeah, it's quite warm in London too for a change. But, yeah. So anyway, yeah. So it will. These models will confidently answer your questions. They are often correct and often incorrect, and that's part of the joy of being a developer with large language models. But now you can get that same confidence locally, which is nice. So we bundle the chatbot, and also this is a playground interface. It's nice for sort of generating unstructured text. So for example, you might say, write a blog post about optimization techniques for large language models, and then press enter, and your model will do that for you. See, it's adding HTML. You'd have to check this all very carefully to make sure it's saying what you want it to say, but if anyone's used ChatGPT before, it's something we're all used to now.
Yeah, funny that sometimes it includes P tag, sometimes it does not.
Yeah, I think this is that one doesn't get closed.
Yeah,
no, that's true, but perhaps perhaps it will figure out to close it later. Yeah, So yeah, that's fairly impressive. I don't know why it decided to make 2 paragraphs, but when but it
You
uses
probably
strong
can
text.
tell it not to include HTML text,
You
right?
can. This is it's prompting challenge, right? And this sort of filtering that you still have to do in a production application to make these things make sense. But yeah, it's a nice playground. It's cool to explore what your model can do. And yeah, so these are our interfaces. Let me just shut this one down. So if you type in iris takeoff shutdown, let's make the screen a little bit bigger, and then the index of the server that's running, we'll manually take that down. And then let's just, takes a little while, and then you can also run the same command, but with a CPU instead of a GPU. So this might work on your laptop with 16 gigabytes of RAM. And again, it will run optimizations, this time specifically for CPU.
They should probably close Chrome before running this.
Yeah, probably in terms of memory footprint. Yeah, and so the optimization process is run, and we can ask the same questions, and we should get same answers. But because we're running only on CPU and not with the power of the GPU, we get the answers back a little bit slower, but still very usable for building applications, especially since you don't have to pay the cost of an expensive cloud GPU.
We're testing locally. This is perfect. Like, it's not instant, right? But like, it's probably sufficient to test things locally before you deploy them on a cluster.
Yeah, that's it. So if you're developing locally, you want to build the front end of your application. You don't want to have to spin up a GPU enabled AWS instance to do that. It costs you $3 an hour, something like that. Whereas something like this, you can build locally, you can test locally, and then when you're ready to go and you need that fast latency, you can deploy to the right hardware that you need.
So let's say if I have a Kubernetes cluster, is there anything like maybe you have prepared Helm charts for that, or I need to do it on my own?
We do, yeah. So if we can actually navigate to, so the Helm charts I'm releasing soon, actually, but I don't have them released yet. But if you go to our documentation here at docs.titanml.co, and our blog, we have it's bigger. We have some how to use EC2 and Google Cloud Run to deploy the Takeoff Server in 2 different. So Cloud Run is it's a wrapper over Kubernetes, basically Knative, I think, under the hood of Kserver, something like that. But either way, yeah. So that's a sort of serverless containerized platform, and then coming soon, we're going to have a tutorial about how to deploy this stuff to Kubernetes when you're managing your own infrastructure.
Because I imagine many people would like to deploy it to their Kubernetes cluster, those who have it already.
Absolutely, yeah. I mean, that's how we run it locally when we we have Kubernetes clusters and Helm charts, etc. So.
And this EC2, it shows you how to deploy with the usual EC2 instance, right?
Exactly, yeah. So you have commands creating EC2. No, this is just create an EC2 instance, SSH into it. There's a comparison to what you might have to do if you were building it yourself, and some timings to show how much faster it will be and how much cheaper the instance will be if you use the optimizations we have available. So if you want to deploy on CPU, if you use powerful CPU, you can maybe get the performance that you want there. And I know GPU quotas on AWS are a big problem for a lot of people right now. So this, it goes over the sort of trade-offs there. And then so that's sort of a more traditional, like, it's containerized in the sense that the server is containerized, but it's a real server in some sense, VM. But then there's a tutorial here about using a sort of pure serverless containerized platform with a smaller model that will start on demand. So yeah, then there's also more information here about the Takeoff Server if you want to check out our documentation for how to get it running.
Well, what kind of models do you support?
Yeah, so we support most of the ones you might have heard of. So
is there a list?
Yeah, there is. So here's.
I imagine it would be interesting to also see the comparison, like how many parameters are there.
Yeah, well, so this is a list of model families, and each of these models
Uh-huh.
has model families has a set of models in them. And this, for example, is one of the new models from Facebook, Llama 2, which got a lot of press recently, and that has models in 7 billion, 13 billion,
Mhm.
70 billion sizes. And yeah, there are all sorts of interesting things. So the Falcon models, which we looked at today, instruct variants of those models. The thing to do if you sort of want to pick models is to explore them on Hugging Face, and I think we've provided a good platform here to try and sort of test them out, see what the performance is like. But yeah, you can see there's here like a range of sizes. These are sort of examples with 1.3 billion models, 20 billion models. Yeah, code models here, Santa Coda GPT-2, small models, etc.
On your side, when there is, let's say, a new model on the Hugging Face hub, there is a new model. There's probably some process that you need to do on your side to enable this model in Titanml, right? Because I imagine you mentioned these optimizations. Is it something you do once on your site and then you serve this optimized model, or how does it work?
No, I mean, so we plug into sort of an open source backend called CTranslate 2, which is excellent in case somebody wants to use some more low level techniques. I recommend that completely. And they're very fast with building new optimization techniques for new models. But we also build our own optimizations into the server and add those as new models come out. And so yeah, there is some extra work that's required when new models come out, and new models come out all the time. But yeah, it doesn't take too long.
Well, since it's open source, I guess somebody from the community could also add support for a new model, right? Do
Absolutely,
you have some
yeah.
instructions for that?
No, we don't right now, but we should.
Okay.
That's a really good suggestion. But yeah, we would love contributions from the community.
Do you want to show something else, or I can continue with questions?
Continue. No, I'm finished with my demo here, really. So yeah, feel free to
Because
continue.
like I already asked about contributing,
Hmm.
but is there already a list of issues or list of things that people can help you with if they want to contribute?
No, we're at the start of our open source journey here. We just put the server live. We've been previously working on it closed source, and I think there's a real gap here for an open source community project to build this kind of productionized server. But we don't know exactly what people need. This is a constant process, and so we're in the process of adding issues and starting our sort of contribution process. But the easiest way to get started contributing is to join our Discord, and we have tons of time to help people get started and to get workflows up and running.
So for you, the main thing you're looking for right now is feedback from the community. So people who go and start using this, and then they say, okay, this is not really what I need, or this is like not the best thing, and this thing is awesome, and you want to get this feedback. And
Exactly.
for the community to share this feedback, the best place is your Discord channel, right?
That's right. That's
Discord
right.
server.
We have Discord server, yeah.
How to find this Discord server? I assume there is a
Well,
link in your
there
GitHub.
is a link here. There is also a link on GitHub repo. Okay, well, it turns out there isn't. That's something I'm going to fix. There definitely should be. That's terrible. Okay. Oh, maybe this. No, that's an email. Okay. Well, okay. As soon as this call finishes, I'm adding a link to the Discord because that is the best place to contact us. But yeah, like I said, it's in the documentation.
Can you show us how to give you a star?
Yeah. So let's go to the github.com/Titanml/takeoff. And here it is.
Yeah, like this repo has to have more stars. So please, everyone, go and give them a star because they deserve it. It's an awesome product. Yeah. And how many people are working on this?
So there's 10 of us internal to Titanml, so we're moving quickly on this internally, but we welcome contributions from everybody.
So I know that some of your future plans include adding a link to Discord in your README.
Yeah.
So that's one thing. Is there anything else you plan to work in the immediate future?
Yeah, so and then we have tons of exciting things that we'd like to add. So for example, there's a lot of interesting stuff around producing structured content from large language models. So if you're building an app around a large language model, it can be useful to know that the responses you're going to get are going to be JSON, say, or are going to be valid Python code or valid, have some structure to them that's verifiable. So that's a feature we're working on right now.
As we saw in the example, the HTML code wasn't exactly correct, right?
Exactly. And that's something that the sampler inside the machine learning model can check on the fly. As long as there's some technical restrictions on the language, but yeah, so that's a feature that we're looking to add. We're also looking to add more optimizations for more models. So we currently optimize, we currently quantize models to 8 bits, which means that we can fit 7 billion parameters and 7 gigabytes of RAM. But we also want to add 4-bit quantization, which is another new technique, which is very exciting and interesting. When then you could fit, say, 7 billion parameter models in your 4 gigabyte GPU. It'd be much smaller, but there's some technical challenges there that we'll be working on internally, and that would welcome any collaboration from the community on. So yeah, speed, and then features like structured content, and also we're constantly working on the ergonomics. So if there's a place where you're getting hung up using the platform, if it's not making sense, then yeah, please help us out.
And I'm curious, so here the command you use is iris, and the repo is called Takeoff. So I assume that Takeoff is not the only thing you have under iris. So
That's
is there
right.
anything else?
Yeah, so I mean, it's so Takeoff is a Docker container and it runs a server, right? Iris is just a small wrapper that essentially launches these Docker containers and then takes them down again. You can use the server without the launcher, and the launcher adds only just some nice interface around it, meaning to clean up the launcher and open source it. But this was sort of, how can we get something else? As you can tell from the sort of quality of the GitHub repo, we wanted to get something out and get people's hands as soon as possible.
So as I understood, this Iris launcher is yet to be open sourced, right? So now it's not open yet.
Yeah.
Well, there is already, I assume, since you can use it, you can pip install it. It's
source available. You can, if you want to dig into your site packages, you can look at the source.
But it's not yet cleaned and released.
No, that's right.
When do you plan to open it?
It's on my list. I'd probably next week for the big what I would say. But if that doesn't come through, then ping me on the Discord and tell me to stick to my promises.
How long is your list?
Very long. List is always very long.
That's like when you're a CTO or a startup.
Yeah.
You have to have a long list, right?
Yeah. That's true.
Well, maybe last question from me. Do you have any advice for people who watch this?
Sure, yeah. I would say explore what's available with local large language models. I think there's people assume that ChatGPT is a million miles ahead, and they're miles ahead, but they're not a million miles ahead. They're getting better and better every day, and I think you can build reliable and exciting applications with what you can deploy locally.
Is there any open source model that is on par when it comes to performance too?
Yeah, it depends on the task, and I think especially with fine tuning, you can reach those levels. But if you look at Llama 70 billion, the largest Llama 2 models that have just come out, and if you look at ChatGPT 3.5, so the slightly older and faster models, you can get that level of performance out of the box. And then if you fine tune that and you tweak it for your own use case, which is something that you can't do easily with OpenAI models, you can definitely get competitive performance.
What I found when using ChatGPT is sometimes 3.5 actually works better. Not only faster, but in terms of the content it produces, it's actually better quality than GPT-4. So
it's a variation.
I don't know what
different models do different things.
Yeah.
maybe
So
different
for
things
some
in the
tasks,
training data.
actually, GPT 3.5 is better. Okay. Yeah. Thanks for the demo. It's
Yeah,
amazing.
well, thank you for having me.
Everyone, go give a star, and yeah, looking forward to seeing more stuff from you.
Okay, great. Yeah, well, thank you.
Thanks.